Hey guys, here I am at home, basically doing my COVID detour, which totally stinks, but it is what it is. And just to kind of remind you about something, I am at home, so my dogs might bark or carry on or whatever. So just ignore them. All right, here we go, man. So hey, last time around, uh, in the first lesson, we were covering some of those introductory terms and concepts. So finally, as we get toward this presentation, toward topic two, we'll finally start getting into some of the nuts and bolts and the heart and soul, really, of what I think makes psychology tick. Okay, so in doing so, we're gonna really look at two main components here in this presentation. The first part being really the research, the studies, things like the scientific method. Okay, and the second half of this presentation will start getting more so into the statistics, the numbers, and how it all comes together to make psychology, at least at times, make psychology something relevant in terms of research for the scientific community. Okay? So, with that said, to make a little connection to the previous video, when we were going through some of those introductory terms and names, uh, you know, as far as the history goes, I mentioned a fellow by the name of Wilhelm Wundt and many, many others, right? But one of the things I was saying is that for quite some time, psychology was a bit of a fringe subject. It would be like today telling your mom or dad that you want to go off and study Bigfoot or UFOs or something like that. It would be looked down upon, right? So that's kind of how psychology was in many ways. And finally, it wasn't until those behaviorists came around, the fellows like Skinner and Watson, that took this subject and they applied it toward the scientific method, where there was experimentation done within a controlled setting. That's very important there. And in doing so, you get data, meaningful data, that makes this relevant to science, right? It's not just feelings, which is important in psychology at times, but it's not just feelings. Now you have data, meaningful data, okay? So, what does that mean? So, here we have some types of research, and the big one that I mentioned a few times already would be the scientific method. The old, if you recall in biology, for those of you who had me, the old look, guess, test, conclude approach. And like I said earlier, the scientific method must be done in a controlled setting. And once again, guys, this applies to all fields of science. It could be psychology, biology, chemistry, whatever. The scientific method is somewhat universal in that regard, okay? Just to move on for a little bit here, you also have something known as correlational studies. Correlational studies attempt to describe behavior. That's key there, guys. That's why it's in bold. They attempt. This is not done through the scientific method. This is not done through any kind of controlled setting. Okay, so the data is kind of hit and miss in that regard. But examples of correlational studies include surveys. Again, you've heard of these things, okay? And we'll talk more about that as we get through this presentation in due time, okay? Surveys, naturalistic observations, and that's where you infer behavior. So, for example, Jean Piaget is watching kids and how they play or whatnot, and he's inferring what does it mean, right? Or perhaps Jane Goodall watching chimps. And again, that's not even psychology necessarily, but it's the same term that applies throughout other fields of science, right? So that's the naturalistic observation. Other examples would be case studies. A case study is cool. It's a story. It's a snapshot of an event of some particular phenomenon, but it's just a story. It's not an experiment. Okay, so it's important. It's meaningful, but it's not sciency. Okay, and finally, longitudinal studies. It's in that same discussion. This is not a true experiment. It's just looking at one person or one group and how they change over a period of time. So, for example, how would a type of therapy help a person improve over a period of time? But that's just one person that you're comparing him to himself. It's not comparing them to any kind of control group or anything along those lines. So finally, kind of getting back to the essence of what makes the scientific method tick, uh, we have to ask ourselves, what is a controlled experiment? So let me kind of present a really stupid example to you. And this example isn't even psychology because it's universal across all the all the realms of science. Here's my dumb example. Does water, or my question rather, is this: does water help plants grow? Well, we know the answer is yes. I mean, it's a stupid question, but make believe for just a second that you didn't know the answer to that, and you wanted to put together a controlled experiment to best assess that. Okay, so does water help plants grow? So I'm going to have some potted plants that don't get any water, and maybe you have a variety, right? Some potted plants get 1 mil and get 2 mil, and some get 3 mil and 4 mil, and so forth and so on. Okay, and finally we can conclude, okay, yes, water helps plants grow. And then if we truly did in the correct format, it's not just yes, water helps plants grow. We actually know the optimal amount. Was it 2 mils or 3 mils or whatever the case is. I'm just kind of obviously making up a dumb example on the fly here. Okay, so if you look in the middle of the screen there, you see the terms IV, and underneath that you see DV. So that would be an independent variable and a dependent variable. And I'm going to be really dumb here once again, and to learn what a dependent variable is, we're going to ask ourselves, well, is it dependent upon something else? So is growth of the plant dependent upon water? Well, the answer is yes. So in this make-believe experiment, the growth of the plant is the dependent variable, and water, which stands alone, that is the independent variable. Okay, but then again, if we're truly doing this in the right format, we would have a potted plant that didn't get any water. That would be our control group, right? And then, of course, this is just as important. We have controlled variables. So every other potted plant in this experiment, the only thing we're looking at is water, right? So we have to have the same size potted plant, the same size, or the same distance from the window, same amount of sunlight, in other words, okay? The same brand of potting soil, perhaps, the same species of plant, the same age of plant. Because if you start altering those other variables, that gives us some form of bias or a confounding variable, which I'll talk about in just a few moments. Okay. Now we have this term here on the bottom that I think is kind of confusing for people at times, and that's the word theory. Okay. So in other science classes, perhaps you hear the word theory, and it has kind of a grander approach, right? Like the theory of natural selection, that kind of thing, where it's broader and grander, like I was saying a second ago. Well, as far as AP psychology is concerned, I want you to think of a theory as a hunch. Like, suppose again that you had no idea water helps plants grow, and one day it rains and you notice your grass grew and it got greener or whatever, and you have this hunch like, little light bulb goes on, right? I think water helps plants grow. So that theory, that hunch, is what leads to the hypothesis, right? That's the whole, again, the look, the observation, the guess, and then you have that controlled experimentation like I mentioned just a few moments ago. Look, guess, test, conclude, right? So I just talked about a theory. It's a hunch that kind of leads to the hypothesis, like it rains and I guess water helps plants grow, that kind of thing, right? Okay, hindsight bias. You see my nice little, peanuts picture here. I'll talk about that. So suppose the Spurs have a game, and I'm like, and then after the fact, you're like, oh, I knew they were going to win. I knew they were going to win. No, that's a theory, which kind of perhaps leads to a hypothesis if it's more of a formal experiment going on, right? But that theory is just that. It's a theory. The fact that they won, like, you have no way of knowing with 100% certainty that they're going to win. That's hindsight bias, okay? It's like this couple, they're starting to date, and in your heart or your gut, you feel like they're not a good match, right? And then they break up a week later, and you're like, I knew they were going to break up. Well, again, that's hindsight bias. That's that kind of a gut feeling, but you didn't know with complete certainty. You know what I'm saying? All right. Confirmation bias. Okay, now this is a silly example, but suppose you love Trump or whatever, and maybe you watch a particular news outlet. Or on the flip side, maybe you love Biden and you might watch another news outlet, right? So this idea of confirmation bias, where you're supporting your own beliefs based on what you watch or partake in, okay, that is very similar at times to group think. And you might recall last semester I was saying like maybe Aggies hang out with other Aggies, they think alike, or Longhorns hang out with Longhorns, the same kind of thing, right? So, anyways, moving on. Okay, so I talked about the experimental design, I think a little bit already. Again, a controlled environment. Now look at that last bullet though, confounding variables. So these would be if I did not pay attention to those controlled variables, like if I have plants in a greenhouse and I'm giving them various amounts of water to see if water helps plants grow, but at the same time, light also helps plants grow. Maybe some plants closer to the window are growing faster. So that's a confounding variable, right? Or you might also recall last semester I showed you a video about poker players. So maybe you're looking at a certain tell in your opponents. That's a confounding variable. That's a bias. And okay, again, does water help plants grow? I'm kind of beating a dead horse here, I suppose. All right. So kind of moving on, here are some examples of confounding variables. But suppose I'm doing an experiment and I'm giving my participants in this experiment a drug to see if it increases their concentration, right? But maybe, like I was saying just a second ago, maybe when I give this drug out, compared to the placebo, maybe when I give out the real drug, maybe I have a tell that I'm not even aware of. Maybe I wink or make a certain smile, like, "Hey, did it work?" I mean, you know what I'm saying? If I have a certain tell, maybe we need to come up with a way of eliminating that confounding variable. So there's a single blind procedure where the participant doesn't know which treatment group they're in, like the placebo or the actual experimental drug. But again, I might have a tell. So how do we eliminate that? Now you have a double blind procedure. And that would be where if I'm running this experiment, if I give the drug to someone else to pass along to the participants, okay? And I think a really important one for the sake of this class is that I don't write my own test. Okay, last semester I wrote all my own tests, but this semester I am not. I'm taking questions directly from other sources, most notably College Board. Okay, so I want you to be familiar with their test, test styles as opposed to mine. So I'm eliminating that confounding variable from your test-taking equation. All right. Okay, examples of controlled variables. Like I said earlier, like the same brand of soil, same species of plant, that kind of thing. Okay, so now we have, let's see, the Hawthorn effect. So earlier, guys, when I was talking about naturalistic observations, that might lead to something called the Hawthorn effect. So suppose you have a teacher and the principal comes in. Perhaps the teacher will act differently. Perhaps the kids in the class will act a little bit differently. Or maybe you're at work and your boss is there. Maybe you act differently. Maybe you get nervous. Maybe you're whatever, right? That's the Hawthorn effect, okay? And I have a little silly video here about, giving the waiter a tip, but I'll put that on Google Classroom for you, all right? Okay, the terms reliable and valid. In other science classes, you hear the words accuracy and precision. So these are the same terms. They're just used for psychology. Now getting into surveys. And College Board will ask you about this. Avoid those emotional words. Okay, and you see that in red right there. So that they will ask you about that. And of course, as far as your samples go, the samples must be representative of your population, and they must be random. So for example, if I wanted to see what's the average height of my students, I'm not just going to take a sample of the basketball team. That's probably biased, okay? Again, naturalistic observations, I just mentioned the Hawthorn effect. So there you see Jane Goodall observing the chimps. And yeah, she'll tell you straight up in some of her documentaries that for a while, the chimps acted differently around her. It took some time before they kind of settled down and acted like how chimps are supposed to act, okay? Okay, part two here. Now we're getting into some of the statistics. You have positive and negative correlations, but here's a very important little point to make. Look at that bottom there. Correlations do not denote causation unless, big fat unless it is done by means of the scientific method. I will explain. Check this out. People who died out of a wheelchair correlates with the people who died falling out of a wheelchair correlates with the cost of potato chips. You guys out there know that's a bunch of nonsense, but they correlate, right? Wink, wink. Here's another one. The lack of pirates correlates with global warming. Well, again, this is a bunch of complete nonsense. So what did we say earlier? Correlations do not denote causation. And there you go again, unless it is done by using the scientific method. Because then you have data which is meaningful. And that was a big part of this lesson early on when I was talking about the behaviorist. Okay, so here we have an example of a positive correlation where both variables increase. You gain more weight as you eat more calories. So the line is going from the bottom left to the upper right. Okay, so both are plus plus. Here you have a negative correlation where the line is going downward. So the more you drink, the less dexterity you have. Okay, that's a negative correlation, plus minus. Statistics here, and you could read through some of this in your textbook, but I do want to point out central tendency. That's a big term here. So if you look on the right there, you see words like median and standard deviation and mean and such. So let's get into that now. Central tendency, all right? So on the bottom left, you see a picture that looks like a nice bell curve. That is referred to as a normal distribution. And you see the numbers, and at some point we'll get into more detail on this. But 68% of humans are within that one normal distribution for IQ. Mean IQ is 100. And then you see the next number, 95%, and so forth and so on. Okay? But then you also have what are called left skewed distributions and right skewed. And to best explain this, just look at the mean, okay? If the mean's on the left, as opposed to the mean being on the right. And I suspect, guys, I'm probably confusing a few of you right now. I probably need to explain what the heck mean and median and mode and all that even is. So give me a second, I'll get back to that, okay? So once again, there you see those numbers, 68 for the first standard deviation and 95. Again, this is for IQ. You will have to know those numbers, 95 and 68. I promise, okay? You have to know those. It's not a me thing, it's a College Board thing, all right? All right. But here we go. Positive or negative skew. So the median, if you recall, is the number right in the middle. The mode is the number that repeats most often. And then the mean, of course, is the average. So let's take a look at our weekly allowance there. We have Johnny, who gets $5. Susan gets $5. Danny, he's kind of the poor kid. He gets $2. But Joe, he's this rich kid, and you might even use the word outlier, right? He's the rich kid who gets $40 a week for allowance. So check it out. Let's do the mode, which comes out to $5. The median is $5. And then you have the mean. Because of that rich kid Joey, the mean is $13. It's higher. So because the mean is on the right side of those two fives, that makes it what? A right skewed distribution. You see that? It's pretty interesting once you get the hang of it. And this also goes to show you that you can make some arguments. Like if you're trying to like tell mom, hey, you think you should get a higher allowance, in this case you would use the mean to support your argument. Okay? I hope that makes a little bit of sense there finally. Okay, there's a little YouTube clip. I'll include that on Google Classroom down the road. Okay, again, determining median, the number in the middle. If you see what it says there, it's the number in the middle when the data is ordered from least to greatest. I know that sounds very simple, but I can assure you guys that I've seen a lot of my students make that dumb mistake, like when they're in a hurry or something, when they forget to line them up from least to greatest. Like here it says 10, 8, 15, 14. Like they just kind of blindly pick the number in the middle. And of course that would be wrong. You got to line them up in order. You got to take that moment to line them up in order first and foremost, right? Okay, so standard deviation, that's a term I've used a couple of times. Thankfully on your AP exam, you will not have to calculate a standard deviation. You just have to be aware of it, that it's kind of like that give or take range, right? Give or take. Like, LeBron James scores so many points, he's within his average, give or take, that kind of thing, right? So earlier when I was describing the IQ, I used the term standard deviation to kind of get into that a little bit more. Again, that's something we'll get into down the road in more detail. Almost done, guys, almost done. Ethics. Without reading into all of this, the APA does have certain ethics where you can't harm your participants in a study. And the same goes toward animals to an extent. You can't just blindly, kill off, rats willy-nilly for funsies in an experiment. They are supposed to have informed consent of anything you do. It's anonymous. They're allowed to withdraw at any time. You probably shouldn't be lying to them unless, in terms of deception, unless the honesty would cause a bias, such as in the Milgram study. I think we talked about that last semester. He deceived his participants, but if he was telling them, hey, I want to see if you're going to kill somebody, that would obviously cause a bias going into this. Whereas with Zimbardo, he was not letting his participants withdraw early on, so that's where you get into some of these ethical discussions, which can be very healthy to kind of iron out, And since I just mentioned the APA in terms of ethics, things you should know from last lesson: G. Stanley Hall was the first president. Calkins was the first female president. She studied under William James. Y'all should remember that name from last time. And of course, Washburn, the first female with a PhD in psychology. She studied under Titchener, who, if you recall, studied under Wilhelm Wundt. And those were the structuralists who were big on insight theory. And Crash Course videos and College Board videos. All right, we out. See you later.